So this is going to be a demo of my highly performant Rubik's Cube solving program. And in some of my tests, this program is capable of solving over 2 million cubes per second, which I find is just absolutely crazy. So I did what any reasonable programmer would do, and I decided to throw the most masochistic, extreme demo possible at this program and just see how it performs. So I decided that I was going to go and generate every possible 2x2 cube, and there's like 3.7 million of them, and then I'm just going to throw every single one of them at this program and just see what it does. So how am I actually doing this? Now this is pretty interesting, but if you've taken courses in upper level math or CS, you've probably heard of a Hamiltonian path, which is just a way of visiting every vertex in a graph exactly once. So some of you may see the parallel immediately, but essentially what I'm doing is I'm going to use a Hamiltonian path for a 2x2 cube to reach every possible state on the cube exactly once, and then solve each of those states individually in a row. So luckily people have done the hard work for me, and they've already found a Hamiltonian path for a 2x2 cube, which I have right here. And what's important about this is it is exactly the number of characters long as there are possible states on a 2x2 cube, meaning each new move here generates a non-seen before 2x2 cube. So as you can see here, what I'm doing is I'm essentially just opening this file, and then I'm reading it character by character, and then this function here is going to calculate the cube state that results from each new move, and then I'm going to save each cube state into a file. And I'm going to call this function up here, and I'm going to open that file that I just made, and I'm going to read each cube state into an array so I can store them and then use them later. And then here I'm going to iterate through the array, and then since every element in the array is a completely unique 2x2 cube, I'm going to solve the cube, and I'm just going to do it for every single cube state in the file, which is like 3.7 million of them, and then just report the amount of time it took and the amount of cubes per second. So with all that out of the way, let's see how this thing actually performs. So it's going to first read, or it's first going to generate every cube and then store it in a file, then read the file, and then it will solve it. There we go. So it's generating all of them. That's going to store them in the file, and now it's going to read all of them and then actually solve them. There we go. Would you look at that? Just over 2 million cubes solved per second, meaning it solved all 3,674,160 possible cubes in just under 2 seconds. That is actually unbelievable. And the best part is this program can still definitely be optimized a little bit, probably not a ton, but I can probably bump this up a little bit more. Yeah, and as for applications with this, I don't even know if there are any, but this is just very, very cool. More to come later, probably.